Hi YouTubers, back doing my chores. Just had to fix a leaky tap in the kitchen and sort out the drain plug in the shower and sink, so I have to do that. But it's mainly to do with little jobs today, and I've got some coaxial cable here, and I've got to make up another lead for aerials. I've got a dummy load to test there, small 20 watt dummy load, 25 watt actually, DC to 1 gig, 25 watt, and I've got some capacitors arrived. It's supposed to be 3 kV rating. I would say there's no way they're 3 kV rating, but that's my opinion. And there's this little watch clock out the motorhome which takes watch batteries, but the cold weather they seem to just die, so it keeps stopping. So what I'm going to do, I'm trying to adapt it to a different sort of battery. It's alright, a watch battery, but when it's on your wrist it's got the temperature of your body keeping the battery warm. When it's not on your wrists they tend to die, the batteries. And the tumble dryer's going in the garage, drying the washing from our holiday or adventure. So I'll carry on putting these things onto this cable. I'm not going to video that, I don't think there's any point. Just lately, when I've been trying to solder cables and things, I've hit a problem, and I think I'm reasonably good at soldering, but very quickly I come to the conclusion that these modern copper cables are not copper at all. They're copper plated steel, and I can prove that with this magnet. I don't know if you can see, there's some whiskers of wire there. If I put a magnet to it, can you see it? They're all stuck. Can you see it in this light? They're all stuck to the magnet, which is telling me, although they're copper looking wires, they're steel wires. So they're not good for a lot of electrical applications. Like your car, for example, if you've got a steel electrical cable, what's going to happen? It's going to rust through if it's exposed to moisture. So this is a word of warning, not all cables are copper. So just use a magnet and test it. Okay, continuing on with my little jobs, and this one's really for myself and my hobby. This is going to be my aerial wire for my halfway horizontal dipole or vertical dipole when I made up my mind. And what I need to do is to get some insulators to go on the ends and things like that. Bit short of spondoolies, cash at the moment, but while I was on holiday I found this lying on the pavement. I'm really not sure what it is. It's a lump of plastic, and what I'm going to do, I'm going to try and make some insulators from it. I'm going to cut these bits here and then drill some holes to see if I can make some form of insulator for this wire. So that's what I'm going to attempt to do, and we'll see how we get on. So it's just cut there, cut there, cut there, cut there. So I've got 2 flat pieces of plastic. Okay, well I cut that bit of plastic up and made 2 insulators. It's about 6 mil thick, and made 2. I can actually make another one there, and I might be able to make another one if I need to. And I'm using these carabiner hooks, I think they're called. These are marked 50 kilograms, maximum load 50 kilograms each one of those, and that'll do for my half-wave aerial, which is going to be this material. And what I'll do, I'll put a loop on this end, and this will go to the 49:1 ballon, but I've got a 9:1 ballon for random aerial configuration as well. And I'm doing it this way so I can actually make it portable, so I can take it off very easily and stretch it to a tree or something like that when I'm portable operation with radio ham. So that's where I am so far. Okay, just thought I'd show you this. This is the end of the long wire aerial with the insulator. I don't know whether I mentioned it. You generally need 1mm of spacing for every 100 volts, you know, to be safe. So that's about 20mm. So that's good. That piece of plastic is good for about 2.5 kV if you take in consideration the insulation. 2,500 volts, that should handle that piece of plastic. It's PVC. This end is going to go to the output to 30, I think it's 39 or 49 to 1 balun. And I haven't cut this down yet because that'll have to be done to SWR, but the other grips are made like that, insulators. Another little job I've been doing is actually cleaning the toilet, and I thought it's about time I cleaned it out. So I've separated this. Sorry, this is a porta potty, Thetford, and I'm cleaning it out. We've only used it for number ones, and I thought I'd give it a good birthday treat. I've took the pump out because it's electric flush, and I've cleaned all this out as best I can. The seats and the water tank for the flush. I've got this is the pump for the flush, which is battery operated, and that's a battery pack. You press the button and it powers the pump, and I've got to put that back together in a short while. Excuse the clunking, it's the diesel heater ticking away in my shed. What I've done, this wouldn't run on these little button batteries when it got cold. It would stop working. So what I've done, I've soldered a couple of wires in the back of this sort of watch thing, clock, and put a standard AA battery on it, and hopefully that'll work better in cold temperatures. Because say these little watch batteries are rubbish. You know, they work okay if it's the watch is on your arm, but if you leave it anywhere, the batteries die. And I don't know how many batteries I've had on this one, and I've got it run on this with some wires. So when it goes in its plastic thing on the dashboard, I shall attach it somehow, a battery on the back, even if it's dangling on some wires taped up. That might do the trick.